And the new idea is called ER equals EPR. ER stands, well, let's first do EPR. How many people here know what EPR stands for? A good fraction of you, good. It stands, of course, for Einstein, Podolsky, and Rosen, but it also is the phenomena of entanglement, quantum entanglement. Now, I'm not going to tell you exactly what the quantum entanglement is. It's what Einstein called spooky action at a distance. I'm just going to tell you a very, very simple version of it. Two things, they could just be two electrons, or they could be two nuclei, or they could be two macroscopic objects, are entangled if, by measuring one of them, you find out certain kinds of quantum information about the other one, no matter how far away that other one is. Let's just call that entanglement. Now, all my physicist friends know that I'm being oversimplified, but there is this phenomena of sharing information between two different distant systems that's called EPR entanglement, and it's a very mysterious phenomenon. And I'm not going to explain it now, we'll just say it exists. That was the year 1935 when Einstein, Podolsky, and Rosen discovered, or at least, let's make it simple, discovered entanglement. It was incidentally a very good year for Einstein. Einstein, I think, had 3 really good years. 1905, when he discovered all of modern physics, except for gravity, except for the rules of gravity. 1915 or so, when he completed the general theory of relativity and understood gravity. And 1935, which is much less famous, in which he discovered this phenomena of entanglement, but the same exact year, he discovered something else called Einstein Rosen Bridges. Or sometimes called wormholes. Wormholes are a solution of Einstein's equations in which you have two black holes far away from each other with a kind of tunnel of space between them. You can't see that tunnel of space. It's in some interior space that can't be seen, but the two very distant objects are connected by I call it a tunnel, I've called it a bridge, I've called it a wormhole, all the same idea. You've seen these things in science fiction, people jumping into wormholes and so forth. I always thought it was nonsense, but not completely. What's the idea? If you could go as fast, what it sounds like is you can jump into one black hole over here and pop out over here. Well, we'll see that you can't do that, but nevertheless, that's what a wormhole resembles. The science fiction idea of a bridge between very distant places. Now, what does ER, that's the bridge, Einstein Rosen Bridge, have to do with EPR, other than they have 2 letters in common? Nothing before 2013. Nobody, and I'm absolutely convinced that Einstein was among that nobody, had any idea that entanglement and wormholes or Einstein-Rosen bridges had anything to do with each other. And after 2013, they had everything to do with each other. In fact, the idea goes with the acronym ER equals EPR. You could call it P equals 1, but nobody does. ER, the idea of a bridge between distant regions of space, and the idea of entanglement are the same idea. So I'm going to show you a little bit about how that works. The rectangle here is supposed to be space, a big region of space. Over here on Earth, we have a bunch of particles. Far away on Alpha Centauri, we have another bunch of particles, 2 clouds of particles. Those particles have never been in contact with each other. They don't know about each other. They're completely separate with no prior interaction between them. I'm going to take this sheet of space and fold it over, not because it's folded over, but just I want to draw it that way to make a point. But it is still true that this cloud over here is far from this cloud because you have to go around this long way to get there. What happens if you let those clouds of particles collapse, shrink? They form black holes. That's what a black hole is. It's the shrinkage and collapse of a star, for example. These could form a star eventually, and after a star, they could form black holes. And those black holes will be completely separate from each other with no connection between them. On the other hand, let's do something else now. Let's take a bunch of entangled electrons or a bunch of entangled particles. Half of them are over here and half of them are over here. Now, how do you create, well, the green line here just indicates that this particle is entangled with this one. This particle is entangled with this one. No, not that one, this one. How do you create such a situation? To create it, you have to create the entangled particles near each other. You can't create entangled particles far from each other. You have to bring the particles together. You've got to let them interact with each other, and they will become entangled. But once they're entangled, you can take the half of them that's down here, separate it. Well, let's say we take this half of them and bring them all around here so that we wind up with two clouds of entangled particles. Now we let gravity do its work. And when gravity does its work, again, it creates two black holes. But the black holes are now connected by an Einstein Rosen bridge. In other words, entanglement and wormholes are in some sense the same thing. Two black holes which are entangled will necessarily have a bridge between them. Two black holes which are unentangled will not. This is what's called ER equals EPR, and it was a major discovery. It seemed ludicrous at first, but it very quickly caught on and is now part of the standard law. What can you do with it? Okay, so let's imagine now that we do have such a wormhole connecting two very distant black holes. One of them, Franklin, has control over. Control means he can do things to it. He can jump into it if he wants. The other one, Linus, has control over. And they're very far away. One is on Alpha Centauri, the other is on Earth, but they have this Einstein Rosen bridge connecting them. Well, with enough care and enough fine-tuning, they can arrange these black holes so that they can each jump into their own black hole and in a very short period of time can meet at the center and shake hands. What they cannot do, at least without some further considerations, which I'll come to, or if I have time, I may not have time, Linus cannot jump into one, pass through, and come out the other one. That can't happen. Now, the fact that it can't happen is both known from the quantum mechanical point of view. It's called the no signaling theorem for entanglement. And for wormholes, it's called the non-traversability of wormholes, the impossibility of traversing through them. And it turns out those are the same phenomena. One quantum mechanical, the other gravitational. Now let's come back to A equals RB. The encyclopedia A in black hole number 1, or in the left-hand black hole here, is encoded in the radiation in region 2 over here. Our problem before was that sounded crazy because somebody manipulating the radiation over here could perturb what's inside the black hole in just such a way that somebody who jumped into this black hole over here would detect that a very, very distant observer had done something to this group of photons over here. That sounded outlandish. But now we know that if these photons over here are entangled with the black hole, which they will be, that an Einstein Rosen bridge, and from outside you can't see that Einstein Rosen bridge, but the Einstein Rosen bridge will open up. And so anything anybody does over here will affect what's behind the horizon of the original black hole. In other words, A equals RB makes perfect sense. Again, It has to do with this basic idea that information is not where you think it is. This is a radical example of it. What about the wormhole side of it? How can it be, why should it be, that somebody who goes into one black hole in Alpha Centauri can't get through the wormhole and come out? Well, one end of the wormhole is in New York, the other end is in California. Think of it as a tunnel between the two places. Why can't you drive through that tunnel? And the reason is that Einstein Rosen bridges, and this is a gravitational phenomena, tend to stretch and expand with time. That's the solution of Einstein's equations, gravitational equations. Wormholes grow. So, who was it, Franklin? I can't remember, Franklin or Linus. If Linus tries to drive into the New York side, he will encounter the fact that the wormhole is growing. And in fact, it will grow so fast that he cannot outrun the growth of the wormhole and will simply never get through to the other side and come out the other side. That's the non-traversability of wormholes. You can't even send a light signal through, because even a light signal will not go fast enough to outrun the growth of the wormhole. That's the gravitational side of it. Is there a quantum side of it? Yes, there is, and I don't have time to tell you what it is. I will tell you what it is. I don't have time to explain it, but I'll tell you that it's a computer science concept. It's called the growth of complexity. The black hole, quantum state of the system is becoming more and more complex. It's very much like this information scrambling that we talked about, having to do with falling. The quantum state of the wormhole evolves, it becomes more and more complex, and that complexity translates into the growth of the wormhole. So these are all these very, very remarkable correspondences which tend to make us think that not just that there are deep connections between quantum mechanics and gravity, but it's at some level, as I said, I'll say it again, they're two sides of the same coin. Okay, so we have the idea of a quantum hologram encoding information which could be far from where the object that it's encoding is. And what is the other side of the coin? The other side of the coin is gravity. I like this picture. It's my favorite one of all.